All right, chapter 4, section 3 is going to be about conics. For the sake of this class, we're only going to be doing parabolas, but we're doing it as a conic section and not quite as a quadratic function. And I'll show you what that means in the next slide. So this is just a visual representation of what we mean when we say a conic or a conic section. Is essentially if you attach two cones together at the very tips, facing up and down, depending on how you slice it with a plane. So imagine you have like those two little paper cups, the little cones, and then you take another paper or a knife, something, and you slice it, right? So depending on how you slice it, depending on how the angle in which you slice it, you get a certain shape out of it. Now, this first one, you see that if it's directly parallel to that plane, you get a circle. If it's slightly angled, you get like this oblong shape, this ellipse. And then next you get a parabola, and then if it goes through both cones, then you get a hyperbola. But for the sake of this class, we're only going to be doing circles and parabolas, right? And this section is just on parabolas. All right, so a parabola, by definition, is the set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus. All right, so the directrix is always going to be the equation of a line. And then one thing to note is that with the directrix, it's going to face away from your parabola. And then your focus is going to be facing. Or that's what your parabola is going to be facing. Also note that the directrix is always going to be a line, right? So it's either going to be an x equals or a y equals equation. And then a focus is always going to be a point, right? It's going to be like an xy point. All right. Between the focus and the directrix is the vertex. You guys know what a vertex is, and you also know what an axis of symmetry is, right? We learned that in the beginning of chapter 3, right? So we just have some extra vocab in this lesson. But looking at this image right here, we see that there is a vertex, which we know what that is. We've seen it before, right? So this point right here. And essentially what the focus and the directrix are is that if I pick a random point on your parabola and you see that there's a point right here, if you connect the focus to that point and the directrix to that point, you get two congruent segments, right? And you can do the same thing with any other points, right? So this point right here, if I connect these 2 points, if I connect the line and the point to this point on the parabola, you get congruent segments, right? If I pick a point way up here on the opposite side and I connect it to the directrix, connect it to the focus, you still get congruent segments, right? So that's the idea of what a focus and a directrix is. You won't need to graph it to such accuracy so that you can see that they're totally congruent. That doesn't really matter. All we're going to concern ourselves with is the general shape of these parabolas. So you guys have seen in quadratic functions that parabolas are going to go up and down. Right. In this section, we include parabolas that go left and right. Right. So what you need to concern yourself with in terms of graphing is make sure it's oriented correctly and make sure your focus and your directrix are plotted in the correct position. Now, standard form of a parabola with a vertex at 0, 0 follows these forms. We've seen quadratic equations with an x squared before, and you know that these are either going to face up or down, right? And it's going to face up if it's positive, down if it's negative, if you see a negative. We also include in this section y squared parabolas. Now these go left and right. Now they go left also if it's negative and right if it's positive. Right, so that's the only new part of graphing these, is you can now graph them left and right. Now you might be seeing this 4py and this 4px. What does that mean? You're going to see a coefficient in the following examples in front of your not squared variable, and that coefficient is going to equal 4p. Now we want to find p to be able to graph our focus. Our focus is going to be p units from the vertex, and that's going to make it easier to graph. All right, so these first two examples with the center at 0, 0, hopefully you'll see that they're not super difficult. It's just a matter of graphing it correctly and drawing the focus the appropriate amount of units away. All right, so let's look at these two examples. First, notice the kind of parabolas that these are. Notice that number one, we have an x squared. So an x squared we know is going to either go up or down. Now a y squared, for example, number two, we know that that's going to go either left or right. All right, so a big difference between these two is just the matter of which variable is squared. All right, so look at this first one. We have x squared equals 8y. Now keep in mind, in standard form, it is x squared equals 4py, or y squared equals 4px. All right, we do have it in this form, right? If x squared equals 8y is in standard form, then we can see that there is, that there's this 8 and this 4p that matches, right? Everything else doesn't match in this problem, right? So what we're going to do is we're going to take this 8 and we're going to set it equal to 4p, right, in order to find our p value. All right, so hopefully we see there's an x squared, a y, just the only thing that doesn't match is this 8 and this 4p. So we set them equal to each other to find our p value. If you divide by 4 on both sides, you get p equals 2. Now what does this mean? So this means, I'll make a note right here, this means the focus is 2 units away from the vertex. All right, so let's make a note of this on the graph, right? So I'm going to sketch a graph really quick, right? There's not one provided for you, but let's just graph it. This is centered at 0, 0. So I'm going to draw the center right here. I know that it's an up-down parabola. And since our p value is positive, right, it's a positive 2, it's going to be facing up. Right, it's not going to be down, it's going to be going up. So I'm going to sketch it, it's going to look something like that. All right, and then to graph your focus, I'm going to go from the vertex. If p is positive 2, I'm going to go up 2 units. And remember, your parabola is always facing your focus, right? So that's one way to remember it, facing the focus. All right, so I'm going to go 2 units up, right, since that's where a parabola is facing, and I'm going to draw a point right there. Now this point as an ordered pair is going to be your focus. All right, so that point as an ordered pair is going to be 0, 2. All right, and now your directrix is going to be in the opposite direction, the same amount of units. So it's going to be p units, but in the opposite direction. I'm going to go 1, 2 units down, right, and then we end up at -2. Remember, your directrix is a line, so I'm going to sketch a dotted line right here. All right, and then remember, your directrix is written as the equation. It's not going to be written as a point. All right, so the equation of this line, it is a horizontal line crossing the y-axis at -2, so we're going to have a y equals -2 as our directrix. All right, and that's all the information that we were looking for. All right, so if you try the next one, same idea. All right, so y squared equals -28x. This is in standard form. This is in the form of y squared equals 4px. And so all we're going to do is match. So I'm going to match. We have a 4p and a -28 that correspond to each other. All right, so I'm going to set 4p equal to -28. Divide by 4 on both sides, and you get p equals -7. All right, so what does this mean? Let me write it down. This means the focus is -7 units from the vertex. Remember that we said that it was a y-squared parabola, so it's going to be opening left or right. Since p is negative, right, we know it's going to go to the left, right? Left is negative, right? So let's sketch our graph. All right, we know it's centered at 0, 0. And we know it's facing left since p is negative. And then I'm going to go ahead and plot our focus. Right, -7, our parabola is facing our focus. I'm going to go 1, 2, 3, 4, 5, 6, 7. And then you end up at a point right here. All right, so this point as an ordered pair is going to be -7, comma 0. This time x is 0. I'm sorry, and x is -7 and y is 0. All right, your directrix, remember, is going to go in the opposite direction of your focus. All right, so I'm going to go 1, 2, 3, 4, 5, 6, 7 units to the right, and then you end up at a line that crosses the x-axis at +7. Remember, the directrix is a line, not a point, so you must write it as an x equals or y equals equation. All right, and then it looks something like that, and that's all the information that we needed. All right, that's essentially the same process that you're going to do for all of these kinds of problems. They vary in difficulty depending on what the p-value is, where the center is, but that's how you're going to approach these problems. All right, so we're going to be doing the same thing for these two examples. You just want to note, though, that these are not in standard form. Remember, standard form of a parabola, you need your squared variable by itself. So look at number 3. In this one, we don't have our squared variable by itself. We want x squared by itself. So to get rid of it, I'm going to multiply both sides by 1/4. All right, you could also divide by 4. It doesn't really matter. It's just if you see the 1/4 as a coefficient in front of the y, instead of seeing y over 4, then that doesn't quite look like something that we've seen in standard form. So it's better to have a coefficient out front, so that way you can easily take that number and set it equal to 4p, which is what we're going to do now, right? So I see that there's a coefficient now in front of my not squared variable, and that's going to equal 4p, just like in the last page. All right, so now to get p by itself, I'm going to do the same thing. I'm going to multiply by 1/4. Right, we could also, like I said, divide by 4. Just a lot of you, if you see this, right, might get a little confused. So we're going to avoid that just by having a fraction instead of a fraction divided by a whole number. All right, so I'm going to have a 1/4 times 1/4, and then this 4 and this 1/4 cancel, and then you get p equals a 4th times a 4th is 1/16. All right, just multiply straight across. All right, and what does this tell you? This tells you that the focus is 1/16 of a unit away from your vertex. So let's sketch the graph. I know that my vertex is at 0, 0. And because it's an x squared parabola, I know it's going to go either up or down. And since p is positive, I know it's going to go up. All right, so it's going to look something like that. All right, so 1/16 of a unit, and remember, our parabola is facing our focus, so 1/16 of a unit can go somewhere inside right here. Right, I'm just making up this graph. It doesn't need to be like super close to the vertex as long as you label it. So that's 1/16 of a unit up. Right, so that means our focus as an ordered pair is going to be 0, 1/16. All right, same thing for your directrix. I'm going to go in the opposite direction, 1/16 of a unit. And then that ends up at the y-axis at -1/16. All right, so the equation for your directrix is going to be y equals -1/16. All right, so not any more difficult than the last page. Just the only thing is you need to make sure that your squared variable is by itself before you start setting things equal to 4p. All right. So we can do the same thing with number 4. Right. Notice that your squared variable is not by itself. All right. So we want to get it by itself by multiplying by the reciprocal on both sides. So I'm going to multiply by 1/8. 8 and 1/8 cancel out. I get y squared equals 1/8 x. Right, and now you can take that number that's in front of your not squared variable and you can set that equal to 4p. So I get 4p equals 1/8. Just like before, you can multiply by the reciprocal. And then you get the p by itself, you get p equals 1/32. All right. Now, since it's a y-squared parabola, we know it's going to be opening either left or right. Left or right. And since p is positive, I know it's going to open to the right. So let's go ahead and graph it. Right, x, y, I know my vertex is at 0, 0. It's going to open to the right. And my focus is going to be 1/32 units from the vertex. Right, and that point as an ordered pair is going to be 1/32, comma 0. Right? You're moving from in the x direction. All right, and then your directrix is going to be in the opposite direction, the line going through the x-axis at negative 1/32 units. So I'm going to have x equals negative 1/32. All right, so once you have your p-value, you have plenty of information. And especially when it's centered at 0, 0, like these first 4 examples, it's pretty simple. All right, so now it gets a little bit different when the vertex is not at 0, 0. We've seen h and k in terms of transformations, right, with the vertex h and k. In a parabola, it's going to be the exact same thing. You're going to see the exact same formulas, just instead of an x squared and a y squared, you're going to see an x minus h squared and a y minus k squared. Right, same thing with the other side of the equation. With the 4p, it's not just going to be a 4py, it's going to be a 4p times the y minus k and a 4p times the x minus h. All right, so that's the only difference here. Just the only difference is now you have a vertex and you use what you see in the parentheses to get your vertex, but there's still a 4p and you still solve for the p value the exact same way as before. All right, so something like number 5, this one is already in standard form. We have our squared variable by itself. All we have to do is first label h and k. All right, so remember, h goes with your x, k goes with your y. All right, so I can quickly graph that just so that we can have an idea of where we're starting. So h is going to be a positive 3, right? So I'm going to identify the vertex first. It's going to be a 3, comma, negative 2, right? Why do we flip the signs? Well, remember the standard form of a parabola requires x minus h and y minus k. That minus that you see with that 3 is not part of the 3, it's just part of the equation. 3 itself is the coordinate, right? Same thing with 2. If I see a plus 2, that's a minus negative 2. All right, so I'm going to go 1, 2, 3 units, 1, 2 down, and you end up somewhere right here. All right, I know that because it's an x squared parabola that it's going to open either up or down, right? So we'll keep that in mind for when we find our p-value. Now our p-value is still going to be whatever's in front of our not squared variable, so I'm going to take that 4 and set it equal to 4p. So I have 4p equals 4, divide by 4 on both sides, and we get p equals 1. Right, so what does this mean? We're 1 unit up from our vertex. Right, so I'm going to graph that right here. I know now we're going to face up since p is positive, and I'm going to plot a point right there. And then this point, it's kind of hard to see in this graph, but this point as an ordered pair is going to be 3, negative 1. Right, we go 1 unit up from our vertex. Right, a way to generalize it, if you have an x squared parabola, right, your focus is always going to be at h, comma, k plus p. And then, okay, so this is for your focus. And then your directrix is going to be y equals k minus p. Right, so you're going to use that y value. That's the one that's changing because you're changing it up and down. Right, so this, I'm going to say this is my focus. And then my directrix, I go down 1 unit. Right, if I go down 1 unit, I end up crossing the y-axis at negative 3. Right, so we have a y equals negative 3. That is our directrix. All right, so what we do is from our vertex, go up or down, left or right, the appropriate amount of units and use that number as your focus and directrix. All right, so we'll do the same thing with the next one. So this one, first we need to get it in standard form. Recognize that your squared variable is not by itself. So to get it by itself, I'm going to go ahead and multiply both sides by -1/4. You could also divide by -4, but again, if you see y minus 2 divided by 4, you might not know what to do from there, right? So make it look like as close to standard form as possible. So we have an x plus 3 squared equals -1/4 y minus 2 squared. I'm sorry, not squared, it's just y minus 2. And then we can identify a vertex. Remember, it's h and k. H goes with x, k goes with y. So then our vertex is going to be at -3, 2. All right, so I'm going to go ahead and plot that on a graph. All right, so -3, 2. I'm going to say that's right there. Right, and because it's an x squared, I still know that it's going to go either up or down, right? If x is our squared variable, it's going to be up or down. Depending on which one it is, we're going to have to find out depending on our p-value. Right, so I'm going to take that -1/4, our coefficient, and set that equal to 4p. And then to get our p-value, I'm just going to multiply both sides by 1/4, right, to cancel out that 4. And you get p is -1/16. Right, so this is where it gets a little bit trickier just because you know since it's negative, it's going to be facing down. So you can quickly sketch that part out. It's going to face down. But it's not going to be at such a clear point, right? We have a little bit less than 2, right? We can see that we start at 2, but we end a little bit less than 2. Right, so to actually find that value, remember, in this part right here, I had said that if it's an up-down parabola, h is going to stay the same, the h coordinate of your vertex, but the k value, you're going to add p. And since p is -1/16, my k value is 2, I'm going to have a 2 minus 1/16. Right, plus -1/16 is 2 minus 1/16. And that's where you end up. That's the y value that you end up for your focus. So I'm going to go ahead and change this to a fraction just so that we can combine it, right? I want to make sure that we get it in an improper fraction so you can find a common denominator and then combine, right? If you multiply the top and the bottom by 16, you get 32 over 16 minus 1 over 16, which is 31 over 16, all right? And that's where you end up for your focus. So your focus, your x stays the same, -3, but your y value becomes 31 over 16. All right. And then for your directrix, you're going to do the same thing, just in the opposite direction, right? I'm going to go up now 1/16 of a unit, right? So I'm going to have a y equals, right? Remember, it's 2 plus 1 over 16th. Now you're going in the opposite direction. So we're going to have the same numbers, 32 plus 1 over 16, and that gets you 33 over 16. All right, and this was all the information that we were looking for, plus a general sketch of our graph. All right, now this is a parabola in standard form. You can tell because the squared variable is by itself. On the other side of the equation, we have a 24 as our coefficient. So I'm going to set this 24 equal to 4p to get our p-value. All right, divide both sides by 4, and we get p equals 6. All right, so then 6 units from our vertex is going to be the focus. Now keep in mind, this is a y squared parabola. That means it's going to open either left or right. And also keep in mind that h and k are not going to appear in order, right? We have an h with the x, k with the y right here. That means our vertex is going to be at 3, 2. Right? So simple mistake to make if you're looking at it and going from left to right, you might think the vertex is 2, 3. right? H always goes with X, K always goes with Y, right? So even though you see it in the reverse, it's not reversed for your vertex, right? So I'm going to go ahead and plot this on a graph. Right, so 1, 2, 3, 1, 2, we end up right here. And I know it's a right-left parabola, and since P is positive, I know it's going to open to the right. So then I'm going to go 6 units, 1, 2, 3, 4, 5, 6, to the right. Right? Remember, our parabola is always facing our focus. And we end up at an ordered pair, 6 units from our vertex, and it's going to be at 9, 2, right? 2 stays the same, the y doesn't change, but your x coordinate changes 6 units. All right, so then you want to do the same thing with the directrix. I'm going to go backwards 6 units, 1, 2, 3, 4, 5, 6, and then you end up with a vertical line going through the x-axis at -3, right? So you go 6 units backwards from your vertex, and then that's what you get for your directrix. All right, so hopefully not super crazy. This is as hard as it'll get. Maybe even like the previous slide, the fraction might be a little bit difficult. But overall, it's the same steps every single time. You want to make sure that you get it in standard form, find your vertex, find your p-value, and then plot your focus and directrix accordingly.